of machine learning algorithms. Here's a list of a few different types. I'm going to talk about the first two on that list, supervised learning, which is learning from labeled data, and unsupervised learning, which is learning from unlabeled data, because those are the most common, but I'll briefly go over the other ones on that list. So semi-supervised learning is sort of a cross between supervised and unsupervised learning, where there's typically a small amount of labeled data and a large amount of unlabeled data. Reinforcement learning focuses on how software agents perform tasks in an environment in order to maximize their reward. And neural networks, based on the representation of the central nervous system, represent networks as systems of interconnected neurons. So that would be good for something like social network analysis. And there are many more. But let's move on to supervised learning. So supervised learning is good when you have labeled data and you know what you're looking for. In supervised learning, the model learns the link between the data and its labels, and it learns how to apply that relationship to new data. The two main kinds of supervised learning are classification and regression. Classification predicts categorical labels, so like spam or not spam. Regression predicts continuous target variables, so regression represents the relationship between, say, housing prices and square footage, or something like temperature and elevation. So something where the values don't fit into a specific category. And you can see on the left there, that's an example of classification, because we have basically our data set, which in this case is handwritten digits and then a label. And on the right, that's an example of regression, where we're predicting a continuous variable basically by fitting a line to it. So I'm going to focus on classification. Classification is probably the most commonly known type of machine learning. It's used to classify data into a specific category, thus working with categorical variables, and it solves the problem of predicting which category a specific data instance might belong to. Classification algorithms are referred to as classifiers, and there are quite a few of these, but I'm going to focus on the naive Bayes classifier. So the naive Bayes classifier assumes that the features are independent. So this means that a certain data point has a certain label that has no effect on what the other labels are in the data set. This is a naive assumption, hence the naive in the name, because it doesn't always hold true in reality. But for our purposes of classification here, it'll do just fine. The naive Bayes classifier is generally pretty fast and performs decently, although more sophisticated and complex methods usually perform better.